Hi and welcome back. So in this video we kickstart a new series of videos where we'll be looking at chapter 12 of our macroeconomics 3 module. So chapter 12 looks at technological progress and growth. The conclusion we made in chapter 11 that capital accumulation cannot by itself sustain growth has straightforward implications. That is, sustained growth requires technological progress. So now that we have looked at instances where there is no technological progress and have concluded that capital accumulation can generate growth in output per worker, but up to a certain point, we must now consider the situation where there is both capital accumulation and technological progress. So this chapter looks at the role of technological progress and in growth. So technological progress has many dimensions or features. One, it can support greater quantities of output with given quantities of capital and labor. So this means that, for instance, given a certain level of capital and labor, improvement in technological progress will improve or lead to larger quantities of output. For instance, think of a new type of lubricant that allows a machine to run at a higher speed and increase production. The second point is that improvement in technology can lead to better products. For instance, think of a steady improvement in motor vehicle safety and comfort over time. So the service or the satisfaction that we get from a Mercedes-Benz that is produced in 2020 is far more advanced than that of the one that was produced in 1990. The third point is that technological progress can lead to new products. To think about this, think of the introduction of new smartphones that we see these days, as well as wireless communication technology in all its variants, flat screen monitors and high definition televisions, as well as smart TVs. These are new products that have come with technology. So technological progress can also lead to larger variety of products. And to think about this, we can also think about the variety or the large numbers of smartphones that we can choose from these days. Okay, so one thing to note is that these dimensions are more similar than they appear. If we assume that, for instance, consumers are interested in the service they receive from products more than just the products themselves, we can conclude that all technological progress does is basically improve or provide more services. And this is pretty straightforward if you think about it. So a better car provides more safety. A new product such as a fax machine or a new service such as a wireless communication technology provides more communication service, and so on and so forth. So if we think of output as the set of underlying services provided by the goods produced in the economy, we can think of technological progress as leading to increase in output for a given amount of capital and labor. So given this, we can then think of technology, or rather state of technology, as a variable that tells us how much output can be produced from a given amount of capital and labor at any time. So what we'll be doing in this section is introduce technological progress into our economy. So to do so, we must first revisit the aggregate production function that we discussed in the previous chapters. So think about the state of technology as a variable that tells us how much output can be produced from a given capital and labor given by n, which are the two variables that we said are determinants of output growth in the previous chapter. So For technological progress, we'll denote it as A. So A will stand for technological progress. So given this new narrative, our production function can now be given by output being a function of capital, employment or number of workers, and technological progress. So all of these have got a positive effect towards output, hence the plus. So this new function tells us that output depends on both capital and labor, and it also depends on the state of technology, which is given by A, such that given capital and labor, given these two, an increase in technological progress A leads to an increase in overall output. So for our convenience, let's restrict this production function even further. So we restrict it by stating that output is a function of capital. It is also a function of labor times technology. Or rather, production depends on capital and on the labor multiplied by the state of technology. This new picture then tells us that, or rather means that we can think of technological progress in two equivalent ways. So that is number A. Technological progress cuts down the number of required labor to produce a given amount of output. So this is because the A basically means that doubling the A or doubling technological progress will produce the same as the quantity of output with only half the original number of workers. So now that there's more technological progress, you need less number of workers to produce the same amount of output as before. So B tells us that technological progress increases the output that can be produced with given number of workers. So given this point, we can now think of AN as the amount of effective labor in the economy. So if the level of technology increases, it is as if the workforce has increased as well. So a doubling in technological progress A is like doubling the number of workers. So if technological progress doubles, it is the same as if the economy has twice as many workers as before. With this being said, we can now think of output being produced by two factors. So that is capital and effective labor, AN. And let's try and explain this using our production function. So given that we have just assumed that output is now a function of capital and effective labor, we can, just as we did with the production function in chapter 11, we can also assume a constant return to scale with this new production function. This means that for a given state of technology A, if the amount of capital is doubled and the amount of labor is doubled, the amount of output will also double. So this is shown by this function that represents a constant return to scale when both inputs double. So this can also be shown generally for any given number represented by x. So an x change in both factors of production will result to an x change in total output. It is also reasonable to assume a decreasing return to each of the factors, being K and effective labor. So this means that given effective labor, an increase in in capital will lead to an increase in output, but at a decreasing rate. And similarly, an increase in effective labor will lead to an increase in output, but at a decreasing rate if capital stays the same. All right. So in chapter 11, we thought in terms of output per worker and capital per worker. This is because the steady state of the economy was a state where output per worker and capital per worker were constant. So now in this chapter, we look at the steady state where output per effective worker and capital per effective worker are constant. And our thinking now is always in terms of effective worker. Therefore, we look at capital per effective worker and output per effective worker. So just like we did in chapter 11 when we looked at capital per worker and output per worker, to obtain the relationship between capital per effective worker and output per effective worker, let's use the general constant return to scale function to denote this. That is, X output is a function of X capital and X effective worker. So if we let the X be equals to 1 over effective worker, and then we will see that we will substitute the 1 over effective worker for all the X's here. And in so doing, we're basically going to get this this function here. And if we assume that the function of capital per effective worker is the same as this function here, we can make a conclusion that output per effective worker is a function of capital per effective worker. So this is straightforward. It stems from the narrative that output is as a result of capital per worker. And in this case, since we're looking at effective worker, we'll make the conclusion that output is a function of capital that is availed to each effective worker. Or put simply, output per effective worker is a function of capital per effective worker. So this relation between output per effective worker and capital per effective worker can also be shown in this figure. So it looks very much the same as the relation we drew in chapter 11, in basically figure 11.2, between output per worker and capital per worker in the absence of technology. So the increase in capital per effective worker leads to an increase in output per effective worker, but at a decreasing rate. This is because there is a decreasing return to capital. So just as we saw in chapter 11 that an increase in capital per worker leads to an increase in output per worker, or rather leads to a decreasing rate of increase in output per worker. We see that in this case, the increase in capital per effective worker leads to a decreasing rate of increase in output per effective worker. So because of the decreasing return to capital, the increase in capital per effective labor leads to smaller and smaller increase in output per effective labor. That's the reason why we still see the trend in our curve going slower as it goes up, or decreasing over time. Okay, so in the next video we start by looking at the interaction between output and capital in more detail. All right, thank you.